I'm going to get started because otherwise we'll never get out of here. I've only got 457 slides, so you better pay attention. Unlike other presenters, I am not going to give them away at the beginning. You're going to have to watch and memorize. There will be questions. So before I go, a bit of sound check. First off, how many people here make music? Of some sort, no, a few of you, right? Like not professionally, that you play guitar, you maybe throw a rock at your children and that makes some noise, you record it, you sell it, you become a viral sensation. I'm just going to just check the audio. Just I tried to check that the audio works. Cool. Right, so come in. So after this is dinner, drinks, and at 8 p.m. is a CF Live podcast recording. So that means behave. Otherwise, I'll keep you in here if you're naughty. In case you're wondering who is this weird person at the front, I'm Mark Drew. I've been a Lucee developer. It was called Rilo, and it wasn't even open source at the time. I've been a CFML developer since it was owned by Alaire. And I've been a web developer since before even GIFs were animated. In fact, I showed someone an animated GIF, and they didn't know how I had done this strange voodoo magic. I have many hats. I'm a lead DevOps engineer at DistroKid. I'm also an application developer at DistroKid. And I wear over a multitude of hats. That's one of them. And those are both metaphoric and real. So you might be asking, what is DistroKid? I asked ChatGPT to give me a definition of this because I presume a lot of people's presentations from now on will be written by ChatGPT. So I thought, hey, so can you help me? And it said it's a popular music distribution service that allows independent musicians, the people that put their arms up in this room, and record labels to release their music on various online platforms. Have you heard of online music? Spotify, Apple Music, or are you all just vinyl people here? Oh, I presume cassettes, sorry, you're more up to date than that. It was founded in 1913 by Philip Kaplan, and you might remember Philip Kaplan if you were here in a few, Freising, was it the word Freising? No, it was not. Germering. He came to Germering and showed vandalism, and that was when DistroKid was taking off. So I've been busy since we last saw each other. Hi, it's been since the before times. It's been a little while. So I've been busy building some apps and working for DistroKid, doing some cool stuff. So what have I been doing? We released a couple of products over the last couple of years. One is called Mixer. The other one's called DistroVid. They both do music stuff, obviously. That's what DistroKid does. I'll talk about Mixer more in a minute because that's what this presentation is about. Surprise, surprise. DistroVid is a way for all musicians to be able to release their music videos to various different online distribution things and, more importantly, get paid the royalties of people watching those videos. That's essentially what DistroKid does. The other product that I've been working on for the last couple of years is something called Mixer. Mixer allows you to master your music before you distribute it. This is a big step. This is a way to make your music sound a lot better. And I can't really show you. Maybe I'll show you and you can listen to it. This is how Mixer works in a couple of minutes. Oop, see? Super fast. So you select a track. This is real time, by the way. I haven't sped this up. You upload a file, and this is very slow because my internet was slow. We then get your music and master it. Now you see we're creating a source file, so we are analyzing your music. We're creating a file that we're going to make various variations of it that you can listen to. So just bear with me for a second. This is fine to wait when you're actually looking at a browser, but when a guy's standing in front of like 200 people, it's really intense. There you go. You can do it. There you go. And that's done. Now what we're doing is downloading. And because I was on German 3G, it took a little bit longer. This is not our fault. This is your internet's fault. So what this is actually doing is downloading a whole bunch of files. Oh, come on, you can do it. They're running down. they're going up to your hotel room, jumping into your computer, and yes, and there you go. So now what's happened here? We've got various options. Now that doesn't sound that much better, right? It's really out there. If you change the intensity of the effect, lower it. Change the EQ of the music. We'll compare it to the original. Pretty shitty, right? Compared to the mastering is amazing. Gives a high dynamic range to your music and makes it really sound great. And then you can download the mastered track file in various different formats. Okay, all with me so far, what Mixer does. You've seen the whole product. And the thing is, with complex things like this, there is a lot going behind the scenes. So in this talk, we're going to talk about what happens behind the scenes. We're going to open the hood of Mixer, and we're going to look at what we call the preview mastering process, because these are the preview files that you get to understand how your music's going to sound. We're going to talk about Lucee's task event gateways that Misha and Zach announced this morning. We're going to have a little bit more detail on that. We're going to talk about Kubernetes, or Kate, I might be calling it Kate 8S or something like that, because Kubernetes, said a million times, is very hard. And we'll try it at about 9 p.m. tonight. All of you will say Kubernetes with me after a few beers, and we'll see how challenging you find it. And we'll look at scaling of workloads. So what's the Mixer preview process? You just saw it. A file went up, and beautiful music came out. Now, generally, it's like some junky file that they've uploaded. It can be anything. It can be an MP3, a WAV, a FLAC, a whole range of different file formats that are coming in. Some of them are compressed, some of them are not compressed. So we have to get that file, take it to process it, and then we have to divide out what are we going to do with that file. We go, okay, so we've got some EQ options. We're going to do brighter, neutral, warmer, warmer. So these are the 3 different equalizer options that we have in our mastering engine. And then we've got different intensities, low, medium, and high. That's great. But what that means is that we have to make 15 different files. So it's not like you just went into your digital audio waveform system and went oh, make it cool, and it did one file. What you've mastered your music 15 times. Actually, not actually 15 times. It's actually 16 times, because we also need to master the original file in a kind of flat way. We haven't actually changed the music to it, but you need to compare it. So if you gave us a FLAC file, we have to convert it to MP3 so you can listen to it as well in that little dialogue. So what happens in our mastering server? What does each of these masterings look like? So we have a mastering server. On the left, we have a whole bunch of tasks. Our task event gateway grabs one of those tasks. It's always running. And it then goes, all right, I've got a task, sends it to the mastering engine, and said, all right, great, fine. And it goes and gets a formula for that, a recipe for that particular job that we're going to do. So it says, oh, okay, this one's a medium bright, all right. So it goes, all right, I'm going to get a medium bright. I'll go and get the original song, grabs it, mixes it up, sends a copy of it back to S3. That's a bucket. I mean, some of the songs that are uploaded might have to go in a certain round receptacle, but that's not for me to say. And then we tell the database again, this is what we've done, and the user goes, oh, as you saw, that little progress bar moves along. All with me so far? Yes. Awesome. Says all the people that work with me at DistroKid. So this is all fine and dandy, but as you might know, we have 16 songs to master. What does that mean? We need 16 servers to be ready to render this stuff in parallel. Well, that's great. You just spin up 16 servers, job done. That's if you had one person that wants to master their stuff. DistroKid has about 2 million users. There might be more than one person that wants to master stuff. So you have to scale it up a little bit. Okay, great, we scaled it up. But to where? 15, 20, 30, 400, 500 servers? It's really difficult to predict that load. Depends on the day, depends on the time of hour, depends on if we've did some advertising for Mixer, right? So we've got the high, I took the numbers out because that's a state secret, and I'd have to kill you all, and and you have the high point of like where more people are performing through it. Do you put it to the low point? Do you put it somewhere in the middle that is kind of just about right? So there's some challenges. We have to scale up, but how much? We have to scale down because otherwise my CTO might get a little bit angry that we're spending several $1 million in servers that are just sitting there kind of like kicking a tire for 90% of the time. And we've got to manage a task queue because all the tasks are in. And what happens if there's more things in the task than you have servers to do it? And more importantly, and this is what I'm going back to my first thing, make sure that it's timely. So the user experience is king here. We worked really hard on that preview player so that a lot of things are very streamlined, so that it feels responsive, it feels like something's happening all the time, because it could have been just a blank page going, waiting, we'll email you when we're done, mate. But anyway, so enter to the task event gateways that Misha's talked about. It's an event gateway for Lucee. What they do is they use a CF component or a CFML page, and it runs every however many seconds. You can define the number of instances that are running, and the listeners, and there's various different listeners that can listen to the task running on error when it starts, when it ends. Next. So there's a few ways to install it. Like, anyone use Lucee extensions? Few of you. So there's a few ways to install it. Standard way, you drop the file into the Lucee server's deploy folder. If you didn't know, Lucee server has a deploy folder. You put a .lex file into it, you'll deploy it. Install into the Lucee server admin, like via the upload form that's there, or you do it via the store. Are we going to put it in the store, Misha? I didn't check before this. Okay, so you just download it from the store. Probably was just there under the not installed, which you can't see. And I installed that one. That's me installing it on my machine. Okay, right. Or you can check out and build the source code from GitHub Lucee Task Event Gateway. Once you install the extension, you get never mind. So what you'll see a new event gateway. So you can go into your web admin and either event the original Lucee task, or you can go to your task runner. So if you go into the web admin and you go to event gateways, you can create a new one. So here, create a new gateway instance. Let's say you're going to create it called task runners, like I've just done. So here's your configuration, and for the blind in the back, you can say, it's got a name, we've already said that, how it starts. If you want to start it manually automatically, obviously you want it. The other one is the package name. That's the folder that I have my components in. So whatever package you have, like testbox, test runners, or whatever package you have, you can put it there. Look. By default, it goes to org.lucee.cfml, or .cfml.tasks, I think, but you can put whatever you want in there. Secondly, if you happen to have CFML-based ones, you can put a folder where they are, the template path where you have your CFML-based ones, so if they're in two different places. And you can say how long it waits to check for changes, because if you change configuration in your task runner, you want it to be reloaded, and this checks every so often to see, oh, has it changed? Let me reload it. The second one, not sure what it means, Misha. You have to tell me because I try to understand it. Check for changes no match before.
It looks for new tasks.
Oh, okay.
Not existing, not that change, but one new introduced.
Okay. So like
So
what?
that's not that common.
Yeah, because you'd start up the server already. But
Maybe it's not that common.
and okay, so let's see how we'd actually use them. So here's a task runner. So it extends the org.lucee.cfml.task. It's just a component, by the way. There's no magic. I mean, there's magic in how it behaves. The stuff that Misha does is magic, but there's no actual magic in how it behaves. So we've got like a whole bunch of properties that you can change that alter the behavior of the task runner. So concurrent thread count is how many of them you want to run. In this case, there's 5. You can say how long to sleep before it gets called. That's before. So you can say, here's 1 second. These are in milliseconds, by the way. and how long to sleep after the call. So you might want to have a cooldown. So whatever the process that's running, you might need a cooldown, either or warm up beforehand, whichever. How long to sleep if there's an error? Because what you don't want is like runaway tasks that have an error and they keep on running. You can say, hey, just cool off, chill out. How long wait for the task to stop? So if you've stopped the Lucee service, it'll take some time to stop, and this is how long you'll wait till that stops, right? Before it'll kill it. And then you have whether you're going to force to stop. Like if you're like, no, really, I want to stop. Stop it. Stop it. And then it stops it. The other part of it is you've got two functions. One is init, which is standard for all components, right? And there's nothing really magical about it. And the other one is a main function, which is the invoke function. Let's have a look at the invoke function. So the init function, for example, I put it, hey, I started a task runner. Wow. But the invoke one is a more interesting one. So you can say, you get an ID, which is like a kind of UUID. I don't think it's a particular UUID, but of this specific task runner. You get the number of iterations. So how many times has this already run since it's been started? Any errors, like the number of errors that it's had. How long it executed last time. So the first time you run it, that's going to be empty. It's going to be 0 because it hasn't executed yet. Last execution date, again, I think it's null the first time it runs, and then it gives you an actual date. And the struct of the last error. So you get like an exception saying the last time I did something, I had an error. So you're able to handle it if that happened. And then you can do some work, do whatever the work it is. In our case, it's pull some stuff out of Redis. That's great, that starts running. But what you can also do is listen to all of the task runners on a server, right? So what I mean by listen to that is that you have a listener. You say which ones you allow and which ones you deny. In other words, you do it like you allow everything, deny nothing. But you can say, like, I only want to listen to these specific task runners. And then you got 4 functions. The init, which we all know. On error, so that will be triggered when an error happens. Makes sense, right? On execution start and on execution end. They look fairly similar to each other, but the on error has a struct of errors, the instance, the task, the iterations, and all the other data that was passed into the function before, but it'll be beyond the error plus all the errors. And you can then like log that somewhere, like saying these had errors and stuff like that. You can also do something like, for example, on execution start a timer, on execution end a timer for that specific function ID, which gets passed in by the ID, how many iterations it's gone or whatever, right? But I can see some problems here. I mean, this is great, this is CFC, but how about my 3,000 existing scheduled tasks that I've written for my server, that CF scheduled task is being run from a server? Well, you'll get a task, everyone gets a task. You can do it any which way you want, right? Any CFML file can be a task. So this is specially designed for your existing scheduled tasks, right? You go to a URL on a server, but now you have to have another server. It's its own server just calling itself. Now, every server can call itself. So all you need to do is to put a comment above a CFML file, right? So with these this is Java doc annotations. So you can read them. They're the same ones that you have in the properties as before, and it will start running. You just have to say, like in the event gateway admin page, where you want them to run from, and they'll just start running. If you remember a few slides ago, and if you don't, my God, your memory's really bad. One of the functions has got a whole bunch of variables that get passed into it. So anytime you're executing a task, it tells you how many iterations happened, et cetera, et cetera. You get those as part of the URL scope. So you have all of those already in there. Because we have a lot of tasks as well, and a lot of them have that, and you want to know, like, if there was an error before, et cetera, et cetera. So, well, we're going to try a demo time. Wish me luck. So I'm going to just look at an app that is kind of like how Mixer works, whereas I'm not going to show you the secret sauce. So, So, for example, in my code, can you all see that okay? Is that to your pleasing? So here's our task runner, for example, and you can see at the top. Can you guys see okay at the back? Is it too small? I can't tell. Really? What? I don't want to do that. Cancel. I don't want to do color theme. We're going to choose a color theme until you're happy. Let's go for wake up. No, all right. I can't see what. Sunrise dark. That. Okay, now your retinas are on fire. Let's carry on. Okay, so here's a task. You saw this before, all of that. So what I have in my init function, I create a variables, a Redis queue. Basically, it's a list of stuff that I need to do. And I say, hey, I started the runner. Great stuff. And then I've got an invoke function, which you saw all the different things. And I go, hey, if there was a last error, I say, hey, this was the last error. I try to get an item from the queue. If there's something in the queue, I execute something. And here I've got something that pretends to do some work. It's like you at work. So it's just pretending to like increase the CPU, you know, it's just like, right? Whilst you're playing on ChatGPT, right? It's like, and then it says, when it's done it says finish the work. Right? So this is the kind of app, but how are we going to put something in the queue? Let's go to a browser and go to my queue. There's 0 items in the queue. Well, fine. I'll add an item to the queue. And now after a few seconds, you see found an item. There are now 0 items in the queue. Starting the work. This will run for about 30 seconds, I think, maybe 10 seconds. I can't remember. And it has how many iterations has gone there. And now we have the really weird 30 seconds that we have to wait. But whilst that's happening, you can see that work is actually happening because you can see here that the CPU is actually going up in Lucee. Let's wait for another little bit. Hopefully we'll do 53. Oh no, let's refresh. See, the CPU is actually going up. And finishing the work, right? So this is essentially it. I know it seems like that's so simple, but this has changed the way we do a lot of our architecture of our applications now. We're able to like run stuff very quickly. We have a task listener that, for example, when it starts, we could start, if there's an error, it would report it to Datadog or Sentry or whatever your data reporter is. And we can do, for example, if a task is started, we say that this is started. This is so amazing the police are going to come and pull me away. Right? So if I now just save that, you can see how when every time it starts. See what I mean? You might not believe me, but if I go, let's put started. And you can see here that it's actually run the CFML version 1, which I'm about to show you. That's running it. So it's showing all the runners that have run. So the same way that we have CFC-based ones, we've got a demo runner, right? And here's a demo runner that has got all of the settings. Can you see this? Is that okay for you? Comments are kind of like, by definition, toned down, but there you go. And then you can have all the variables. I parammed them just so that I can print them out if I need to do. Yeah, let's call that. Let's get the task listener. Let's quieten it because like having all this output is a bit, calm down. Cool, so that's kind of like one piece of the puzzle. All right. So task gateways are always running. They can replace scheduled tasks in some cases. Is a component or simple CFML file, and they can have listeners that track progress, do counters, and log any errors. Pretty cool, right? Okay, so where were we? We can now process files. We can do it all the time, but how do we scale up as we need, right? Here comes Kubernetes, or K8S, because there's 8 letters, and if you, and it's called Kates. And behind you there's meant to be a guy doing container orchestration, because that's what Kubernetes does. But his hand is very deformed, because apparently AI doesn't know what hands are. So thank you, Dali, for that horrific sausage hand. So who's heard of Kubernetes here? A few of you, okay, great. Well, I'll tell you what, Kubernetes is dangerous. That's why the police are here. It's an open source container orchestration platform. Does that mean anything to you? So like, it's developed by Google, but now maintained by the Cloud Native Computing Foundation, which is CNCF, which I always thought was a French railway, but you know. It's got some great features and benefits. It's basically automation of containerized applications, their deployment and their management. In other words, who knows what Docker is? Quite a few of you, right? So it manages Docker containers essentially for you, right? Rather than you starting up and shutting them down, it can deploy them, it can do scaling and load balancing, scaling being the bit about this whole presentation, does fault tolerance and self-healing mechanisms, which means that if a container starts misbehaving, it takes it round back, shoots it in the head, and brings a fresh new one in. Well, or just kills it. It does kill it. It literally says Docker kill, right? You're looking at me. It's got simplified resource utilization and allocations, so it has some ways of running a whole bunch of containers in a whole bunch of machines. There's some terminology I need to just tell you, and there will be testing. So there's some Kubernetes terminology, like a pod is the smallest and most basic unit in Kubernetes. It's basically a container. You can think of it as a container. It's not quite a container. It could be 2 containers together, but they're very tied together, right? So, for example, these 2 containers always go together for whatever reasons. They love each other, but generally it's just one container, right? The next part is the deployment, which is how you manage the life cycle of these pods, right? You say like, well, there's going to be these many pods by definition, and when I change what image it is, there should be only about 25% of them dead. Is this like a sound effect, or is this like actually? I thought you were pulling my leg like every time I do something, like sound effect. Right. Service is a way to have a unique lookup for this deployment, because this deployment might have hundreds of different containers running, so you have a service which is a way to name it internally. There is a horizontal pod autoscaler, which means that it can scale the pods horizontally. In other words, you're not getting more machines or anything like that, you're just getting more of the same, but being able to point to them by the service. We'll say, okay, we've got now, instead of having 10, we have 100, and we can just choose them. I'm going to do a quick comment to what an ingress is it exposes a service to the world. So it's basically the HTTP or HTTPS. So like that's how you'd want to do, like, for example, a high availability website, right? You'd use an ingress. You can think of it a little bit like Nginx. It's like it's a load balancer or a proxy, a front-end proxy. And finally, the actual one is a node, is the actual machines that stuff runs on, right? Like it doesn't run in the cloud, there's actual machines. There might be virtual PCs or whatever, but it's the actual tin that you give to a cluster and say, hey, we need to run 100 containers, but I'm going to run it on this Arduino. It's not really going to run, right? You need like hundreds of Arduinos to run all of that, or hundreds of PCs. So that's what a node is. And I apologize, because Google hates you and has done everything in Kubernetes in YAML. So don't blame me, I am just a messenger, but this is it. YAML sucks, I realize, but the reason they've used YAML is so that everything can be decoupled. So you can have a definition of a node, you can have a definition of something else, and they look each other up and connect, rather than having to have like welded connections in between them. So let's go through this. So at the top, we've got like the API version. Everything in Kubernetes is an API. It's actually an endpoint. You can think of it as REST. And the type of thing it is. So this is a deployment. It's an engine. We've given it a name. So when it comes up, it says Nginx deployment. We have a spec. We say we have 1 replica. That means we want 1 pod for this deployment. You can have 100 pods. You can have whatever you want. And we're going to say is going to, and the replicas that we want is that template below it, the Nginx app. Great. Boop, boop. And then finally, we have the spec of the container, Nginx. Everyone knows what Nginx is? Yes? One person put their hand up. Thanks. You get a T-shirt because you knew. I don't know what size you are, but you get a T-shirt for knowing what Nginx is. You could have all had T-shirts. You're lost, man. So yeah, and the container port is 80 because it's a browser. I've realized I've only got 14 minutes, but all right, that's going to be a long. And that's a deployment. So a service is a way to point to that deployment. So basically what we're saying, it's the API is v1, the API. We've got an Nginx service. We're going to select the Nginx app, which is the one that we created previously. We type as a node port. Node port is saying like we're going to bind to each of the nodes. Those computers are going to expose a port, like port 80, and we're going to bind to that. And finally, we're going to say the port on those nodes I'm going to expose as port 80. It's like port forwarding, right? Pretty easy, but they had to do it in YAML because they hate you. And how we're going to do this is using something called Minikube. Minikube's a good way to have a cluster on your laptop, right? Because testing all this Kubernetes stuff might be fun, but it might cost you a little bit by spinning up several hundred machines. So it's good to have it on your laptop. It's really great, much cheaper. There's some slight variations on how it behaves, so because it's a laptop compared to all of the architecture in AWS, but it's a really good little tool. It's also fun. It uses emojis. I like it. So what we're going to do is how to deploy it. So kubectl, kube control, is how you interact with Kubernetes. So we're going to apply that deployment.yaml. Those are just YAML files. And we can monitor the status of the deployment. And we can then get a proxy, a connection into that deployment and see if it runs. Shall we try it? Time for fire. You just want to, you have a T-shirt. You don't have to. Let's try this. All right, so let's have a quick look. This is our example deployment. Yeah, my laptop's going to be on fire at the moment, running all those machines. So it's better if I showed you some of the stuff. There you go. That's much better, isn't it? So let's have a look at some deployments. So at the moment, this is the dashboard for Kubernetes. I'll expand it when there's something interesting to see. On the left are all the objects that it has. So for example, how many nodes, how many services, how many ingresses, blah, blah, blah. How many pods, for example. At the moment, we can see that there's no pods. So let's have a look at deployment. We're going to deploy that Nginx service. So where's our Nginx service? So we've got, here's my script that's going to do it for me because I'm very lazy. You should be lazy. You should never type a command all the time. If you do it all the time, just do that. So let's apply this, right? Okay, so now we're waiting for the deployment. You can see deployment Nginx rollout, and you can see the Nginx deployment is there. Do you want me to change the color because it's really dark, isn't it? Don't know where you change it. Tough. You're going to have to just come to the dark side. So you can see this is rolling out. At the moment, the status is pending, right? Because it's starting up some containers. We can probably see what the pods are. And you can see that there's an engine pod. And you see, like, there you go. And welcome to Nginx. It's popped up because I created a service for it, and you got Nginx running. If you can load it loads of times, but if we go back to the Kubernetes dashboard, we see that we have a pod, in other words, a container, and you might go like, but what's a pod, Mark? You can actually log in, or share logs on it. So here you go. So this is, if you know Nginx, this is just Nginx logs that are running. And that's it. That's that running. Cool. Amazing. Okay. So hopefully what happened? An Nginx deployment Nginx deployment was the name I gave it. Deployment was created. A single Nginx pod was started and deployed. I created a service to point to that deployment to say, hey, make this available to everybody. I used Minikube to just create a proxy to it so that I could connect to it, because the service allows all the other servers within the Kubernetes cluster to connect to it, but we wanted the great unwashed to be able to connect to it. So we connected that, and we saw Nginx being served from our cluster. Cool, right? Awesome. But first, an apology. And Kubernetes is kind of complex. I'm trying to show you like what it does very quickly. It's kind of complex, but it's really powerful. It allows you to do a lot of cool stuff, and it's very decoupled. So when you first come into it, there's all these different YAML files, different commands that you have to get to know, different names because for stuff like that. And then people obviously are very smart, and they create things like Helm charts, et cetera, so it becomes even more complex at a second layer. But bear with it, it's not bad in the end. But the important thing is that we wanted to scale this stuff up, right? Great, you've served Nginx. Woo, I hear you say. But let's go back to the app that we saw earlier and see what we can do with that. So we built our image. What we're going to do is build our image, because we want to create a Docker container and push our image, create a deployment service, a deployment and a service, and then we're going to create something called a horizontal pod autoscaler, which I'm going to show you. We'll deploy some Redis stuff, because Redis needs to be backing all of this. And it'll load scale like a super duper. We'll start asking it to do stuff, and it'll do stuff. And watch the listener log stuff, and watch the workers do stuff. Who's in for that? Yay. See, that's much better. Okay, let's do that. All right. Thank you. Great. So here's my task service. There's loads of files in here because I've been doing this for a little bit, and I'm cleaning up and I'm making sure everything's just perfect for you guys. But let's have a look at our deployment. You can go. So it looks like it's a lot, but it's a deployment. I'm going to call it task server. There's one replica by default. We have our strategy, in other words, how we want to roll stuff out. Because you can have, who knows, blue, green, and canary, and those kind of things, right? This is kind of our rollout strategy. Well done, well done. Do you want a t-shirt? Awesome. I don't know what sizes they are, so you get a t-shirt. And if it's too small, blame Gert. So this is telling how we want to roll stuff out, like what's the surge of new containers we want to create that are new ones, and how many should be unavailable at any one point, right? Sometimes you want to say like, no, I'm going to destroy everything, and all new ones are going to come in. This is when you've got like big breaking changes in your software, right? That you can't like just flow code into it. Then we got the selector, which says what I want it to do, template, blah-de-blah-de-blah, and here is our container that we define. Eagle-eyed among you will say image pool policy never. That means to go out to the internet or start looking out in the internet first. I've given Minikube the images it needs. Doesn't need to go out to the internet to get them, because demo gods hate you. And if you try to do anything downloading from the internet, it's not going to work. You can pass in specific environment services. So, for example, you can say which tier this is. So you can have run staging, production, development, blah, blah, blah. And you can then limit the amount of resources, because you don't want like a runaway Lucee container to take down the whole cluster, right? You can say, hey, you can only have 2 gig of memory and 1 CPU is your max. But you can be around. This is your normal one. And then you can say, here's a port, and here's a container port. In other words, this is what you're exposing, saying, Lucee uses port 8888. And you notice that I had a service.yaml before, like in a separate file. You can actually put them all in the same file, because why would you need to do so many files, right? So let's deploy this. Are you ready? Because I am not. Right, I'm just going to see deploy. All right, so, okay, so this is my whole deployment script. Cool, huh? Let's do it one by one. That's going to be easier. So let's create a deployment and see what happens. So K apply. K, kubectl, if you've typed it 4,000 times this morning, I put an alias to K in case you're wondering what the K is. Because I always mistype kubectl and everything gives me errors. And anyway, I'm old, stop it. All right, so a new deployment has been created. Let's go and have a look at our deployments. Task server. So it couldn't contain an image, it couldn't find it because we said there's no one there. All right, let's build this then. So what I'm going to do here, does anyone here do Docker build? Do you know what Docker build is? It's going to wrap up your app, it's going to throw it in. Okay. So this is going to take a little bit of time. So what I'm going to do is I'm going to build it. It's going to certain tag. I'm going to tag it to the latest. I'm going to start it. And then the final one, so this is a chicken egg situation. I don't have an image in there, so I have to tell it it has to use some image, right? So now I'm going to build the image and tell it to use this image instead. All good? All right, let's do that. So what this is going to do, this is going to build a Docker image. It's going to tag it, and I'm going to send it to Minikube. And then I'm going to tell the deployment that that's the image I want to use. It's really hot in here, and run active file. So there we go. So now I'm building that app that you saw before. I'm just wrapping it up as a Docker image. And this is the bit where I can have a little drink, and we can watch a terminal. Exciting, isn't it? There you go, and now we're starting to load the image into Minikube because we didn't want it to. We didn't want to start pulling stuff from the internet. Images can be kind of big sometimes, so pulling something during a demo is a bit of a pain. So what we're creating here, we've already created the deployment and the service, so we can gain access to that, but there's no image, so the container is failing. Right, so you can see can you see there? It says I can't get this image. I don't have this image over there. Right? And once this is done loading into Minikube, it takes 30 seconds, and 30 seconds up here feels like 4,000 years. Quick quiz. Remember what the label is. DistroKid/teg demo. Okay, setting the image to DistroKid teg demo in Kubernetes. Image updated. Let's see what happened. There you go. You see the task server is fine. Look at the pods. We've got our task server pod over here. All right, so what we've done is build an image, send it to Kubernetes, it's gone up. Great, we've got one pod that's not scaling, is it? So what we can do is a horizontal pod autoscaler, which is the easiest thing to say lots of times, which we'll do at around 8 o'clock after you've had a few beers. We'll all sing Kubernetes and horizontal pod autoscalers together. So the horizontal pod autoscaler, which is I'm going to say this 15 times, has a spec. It says how many are the minimum amount of replicas do I want to scale down to, how many are the maximum that I want to scale to, and under what resource utilization, right? It's like, when do I hit a limit for me to scale up, and how quickly? So the average utilization is 30%, and then I can do what I want to scale up is a task server. I tried to scale it down very quickly for you guys, but obviously Kubernetes does not want to do that. Kubernetes wants to provide good service throughout most of the time. So for demos and scaling down really quickly, Kubernetes is going like, why would you want to do that? So I've tried to change it, but it ignored me. Fine. So let's apply this. K, apply, -f, K8s, tasks, horizontal pod. Who said that? You've got a t-shirt already. There we go. So we created the horizontal pod autoscaler. And that's not going to change much because we haven't got any load or anything like that happening, right? But if we look at our deployment here, which just refreshed, because we now have somewhere over here. Oh, that's a pod. What am I doing? If we look at the task server, we now have pod status. There's updated one. We can actually scale it from here, but this never works if you've got a horizontal pod autoscaler. But if you look down here, we can see a horizontal pod autoscaler that's telling us task.hpa, 1 replica, 10 replicas, and when it was created. From the command line, we can actually go and get its status. So I presume you can see that. Okay, get HPA, minus watch. You can see the targets. Can you see this okay? Everyone can see the numbers? Good. So you got task HPA, which is a horizontal autoscaler. The reference is a task server. At the moment, it's got 6% target, so that's how much the CPU is current, and its limit is 30%. The minimum pods is 1, great. Maximum pods is 10, and however many replicas you have. Great, we're like running pretty chill. Okay, let's unchill that. Deployments. Okay, I'm just going to have to quickly update my. What we need to do is insert Redis as our queue. So let's do that. Redis. So very quickly, okay, apply minus F. Okay, it is Redis. I do this even when you guys are not here. I just talk to myself. So I've created that one. Okay, so now we have Redis hopefully coming up. And guess what? We don't have images again. Thank you very much. So let me just throw the images into Minikube. You don't normally get this because generally clusters are connected to the internet by a big fat pipe. Laptops are not connected to the internet by a big fat pipe generally in presentations. So I'm just going to load Redis into that. I'm going to go fix this one and get Redis Commander. Redis Commander is just the UI for Redis, if anyone has used Redis. MK image. If you see me do a typo, do let me know because you know it's cruel to watch someone. Okay. So now you start seeing that Redis has come back online. It's got the image. It's got that. Cool. Once that's done, you should be fine in a second. There you go. So that's loaded. Now we have Redis. We've got our Lucee app in there, but we have no scale. Let's go scale it up. So as I said, we've got services that need to be pointed out to the outside world, right? Because they're pointing to the Lucee server, but they're not doing anything there. So let's do service. Book to you too. Tasks, server. So there we go. So here's the app that you saw earlier, but it's now coming from Kubernetes, right? I'm just going to split my screen so we can see what's happening a little bit. So doop, 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 doop. Jesus, that's really tiny, even for me. Okay, so can you see that a little bit bigger? Ein bisschen bigger. Okay, now what I'm going to do, before I did one task, let's put 100 tasks. So we've added 100 items to the queue. Go on. Please. And of course, I was prepared for this. So here's a video of that happening. Thank you. So you add 100 items to the queue, and you see that there's no running tasks. And eventually, you see 5 running tasks. They start running. The pods start scaling. And it just takes a little while. I can't remember which video I did here, by the way. So what I'm watching for here is how many pods are running. At the moment, we have the Redis, the task server, and the Redis commander. The pods are the minimum containers that we're running, right? So we're going to watch this for a second. We'll just fast forward in time because as lovely as Kubernetes is, it's not very presentation friendly. So you start seeing that pods will start coming up. And you see they're pending. In the pending state is because they've just started up a pod. It's kind of like starting up.
Which one of them do you like?
I'll go for the skin flesh-colored one for 5 minutes. And yeah, so this will start creating pods. And as you can tell, if the video is still running, we've got about 70 items in the queue. As these servers come up, they'll start picking items from the queue, and this will keep on scaling. Eventually, you run out of stuff that's in the queue, and the servers and CPU will start coming down. Let's see if we can. And now you can see the CPU usage. Anyway, so eventually it will all come down. You don't want to see me coding this whole afternoon because I just recorded 3 hours of it. Oh, this is a video. All right, that got me confused. All right. So essentially what will happen is that more and more pods will scale up, and eventually after about 30 seconds to 5 minutes, 5 minutes is actually generally 300, not 30 seconds, 300 seconds, which is 5 minutes. Pods will start going, well, actually these are useless, and they start being terminated, like the ones that have 0 CPU. And that's how the scaling will go. Cool, so just final thoughts. And Task Event Gateways are great for churning through tasks. We use them for a lot of work that we do, some big work and pick up work and just do that stuff. One of the big innovations, I think, having done this for a couple of years, is that you can work with existing scheduled tasks. That's a big game changer because you can remove a single point of failure in your architecture. And I think Kubernetes is a great way to run high workloads and also high scaling. Now that gets a little bit more complex with ingresses and things like that, with how you architect your application. And, well, it can scale horizontally. It can also scale vertically because the vertical autoscaler, but that's creating new services and stuff like that. Anyway, you can find me here, and I think it's about time for one of those, isn't it? If you have any questions, you can ask them because we've got 2.5 minutes, if my math is correct. Yes? And I have T-shirts, so you should ask questions. You know what I'm saying? No questions? Or is it just too hot? Ben?
2 questions.
Okay. He wants 2 T-shirts.
The task gateway, is it living only for one execution? Or
No. It persists. So, for example, that's where you can do stuff in the init, and you can create variables into it. So it is cached. I don't know exactly where it's cached. That's the person that you should ask.
And then second question, is it called in the context of the application, like managing the application scope together?
Yes, but there's a big but here, as always, right? Is that you can have access to application scope if it's like underneath the application scope, but if the application scope doesn't exist, the task gateway will start at the beginning. You see what I mean? So your app might not have had any requests to it to initialize. Yeah. Now you can fix that with autoscaling because with your deployment, because you can say, hey, before you start doing anything, hit this page. Like the moment it starts up, start hitting that page on a pod, and that's like index.cfm or whatever. So the applications will be done. Here's your other T-shirt for your other question. Yeah, Dom?
Can you programmatically pass an instantiated component as a task runner?
Misha?
The task runner is an instance that stays. So between iteration, it's always the same instance. So you can store within whatever you like. So for instance, if I have a component that's managed with injections, wipe up or something, so okay, get this component now. This is kind of got a whole load of stuff in it. And now
Sorry.
now I
Sorry.
want to say, hey, run a system, use the instance of the CFC browser versus just something that lives in a directory and
I mean, we haven't found too much of a challenge because that's like dynamically loading them, mainly because of how we're running all of this stuff. We've got it baked into components, and that's what the container does. It's just a task runner, right? So there's no UI, there's no application on it. I lied, there's application because it's also doing the REST API to do some management tasks that are very specific for that.
But maybe you can handle it in the internet.
Yeah.
Be very careful when you do this. When we first did historically, we had the problem that there was a background process running which was throwing an error, and the CPU on my laptop was like cranking away and we weren't working stuff out. So just output, like console is really useful.
Yeah. I mean, system output or Redis or whatever, but yeah.
No, it's just output.
Yeah. Also, one thing, was there another question? I didn't, yes.
So is one instance of Lucee of your tasks enough, or do you run Lucee with your task runners also in a Kubernetes network?
We have for the jobs that we're doing, we have a Lucee task service. Does that make sense? It's like, it just does running of tasks. It doesn't take any other load.
So it's one installation.
Well, it's one image, yeah, and like millions of them, yeah. For doing that job, right? So, don't know which one you want, small or Excel? I think you're a medium, but you know, you look sexy in that. Sorry.
It's not related to tasks themselves, but what version of Lucee image, Docker image you use it? Because I saw you warming it up. And
Yep. 5.3, that one.
And this is official.
This was just, I know we're Lucee presentation. I just didn't care. I just did like Lucee latest, and I think it's a 5.4, 5.3. So it's that. So. Oh yeah, okay, sorry. Yeah. You might have to swap T-shirts for like, do like a T-shirt swap. Anybody? Any other questions? I have one more T-shirt.
Yeah, actually, Mike's obvious. If you actually have the task runner running Lucee task in one container, you actually have the need to spin up several Lucee containers doing some really web stuff, sustaining your UI. Then you obviously run into the problem of you having sessions in those containers.
Yeah.
How do you expose the containers in such a way that the request from one client always goes to very same?
Task runners don't get.
That's not for task runner.
Oh, but for this, we use. I can answer as well. We shared session storage, so you can say you can create a cache in Lucee and say this is for session storage, and you just store it there. So, for example, you'd have like one instance of Redis, just as an example, just because I had it there. That's where you store all your sessions.
Just have one shared session storage.
Yeah, and you like you say your session is this sort of session is clustered. I can't remember exactly the syntax, but session cluster equals true, and you say this session store equals your, Redis session store, and they'll be stored in there. And each server that a person goes to, it goes like, hey, do I have your cookie in my list? And it gets your session, and it just works. Any other questions? I've run out of T-shirts, but happy to answer questions without T-shirts.
You still have a T-shirt.
The T-shirt off my back, Jesus.
There are Adobe T-shirts outside every round.
Are there? Well, okay, then there's no more questions then. I'm joking, you kind of, but anyway.
Are you thirsty?
Yeah, very.
That's good because the beer's already waiting.
Then let's go!